Hey everyone. So in this video, I'd like to talk about sign numbers. So far we've only worked with positive numbers, which are numbers that are larger than 0. Right, so some examples might be 5 or 42 or 100. But some ideas can be represented well with numbers that are less than 0. And so these are numbers that we call negative numbers. Right, so some examples might be -7, -3, -16, and 1/3. These are all examples of negative numbers, and we use this sort of minus sign in front to denote that these numbers are negative. And so what does it mean for us to look at the number -7? Well, just like the number +7 is 7 more than 0, well, -7 is 7 less than 0, right? So here, maybe just to write that down, this is the number that's 7 less than 0. And so one thing I want to emphasize is that although the symbol that we have in front of this 7 here, it's used to denote the negative number -7, it looks a lot like a subtraction sign. It's not the same as subtraction. This symbol is just there to tell us, hey, this is a special kind of number. It's a negative number. It's not necessarily a subtraction sign. So that's one thing I'd like you to keep in mind as we work through with negative numbers. So one way we can visualize numbers is with a number line. And this will help us make sense and understand how negative numbers work. So a number line, this is just the line that we use to arrange all of the numbers. And so here, smaller numbers are further left on this number line, and larger numbers are further right on this number line. And so if I position 0 in the middle, then we can position the positive numbers to the right of this number line. Here would be 1, 2, 3, 4, 5, 6, all evenly spaced out. And of course, I have this little arrow here on the right just to share that there's always larger numbers to include. So this number line, really, you can imagine, is going on forever. We just can't write down all of those numbers. And we can also go in the other direction, right? Numbers that are smaller than 0, right? 1 smaller than 0, 2 smaller than 0, 3 smaller than 0, right? -4, -5, and so on. So these smaller numbers, these negative numbers, lie on the left side of this number line. And so here, I've only listed out the whole numbers and the negative whole numbers, but of course all of the numbers in between also lie on this number line, right? So here, if I imagine this position on this number line, well, that might correspond to the number 2.5, right? That's lies on this number line, but I'm not going to list it because we already have so many numbers to list. So here, let's use this number line to compare some quantities and get used to how this number line works. So one thing I like to mention, and this is something I'm sure you already know, is that the number 2 is less than the number 5. Right, so this is something I'm sure you already know, but I just like to use this as an example to get used to the number line and notice that the fact that 2 is less than 5 can be seen on this number line as the fact that 2 is further to the left than 5 on this number line. All right, smaller numbers are on the left, bigger numbers on the right, and so if 2 is on the left of 5, we can see that 2 is smaller than 5. And so some symbol that we use to express that mathematically is we use the is less than symbol. Right, so here, this symbol is used to represent is less than. The left side is less than the right side. So we might write something like 2 is less than 5. So sometimes people have a hard time remembering which symbol, whether this symbol represents is less than or is greater than. So the bigger number should be on the right where this symbol opens up towards. Sometimes people refer to this symbol as they think of it as an alligator mouth, and the alligator eats the larger number. If that helps, that helps. But here, this is what we refer to as the less than symbol, and the left number should be less than the right number. Equivalently, we can write down 5 is greater than 2. Right, so this is the same idea, just kind of taking a different perspective, more focused on the number 5 than on the number 2. And we would write that down with the is greater than symbol. It's just the same symbol but flipped around, right? The open direction is sort of to the left, right? The number on the left is greater than the number on the right. We would write 5 is greater than 2. And you can see again that this symbol opens up towards the bigger number. So these are symbols we'll use more in the future, but I just wanted to introduce them here so we can really compare different numbers on the number line. Maybe let's talk about how negative numbers compare to a positive number. Maybe let's compare -3 and 2. So which quantity is the larger value? Is -3 larger or is -2 larger? Well, here if we look at our number line, we can see that -3 lies to the left of +2. Right? -3 is less than +2. And although 3 might sound like a larger number to you, the fact that it's negative is telling us it's further left on this number line. It's a smaller number than +2. And if you think about temperature as an example, hopefully this idea is pretty clear. Right? Here, is 2 degrees Celsius or 2 degrees Fahrenheit colder or warmer than -3 degrees Fahrenheit? Well, 2 degrees Fahrenheit is warmer. It's a larger temperature value than -3 degrees Fahrenheit. And we can see this on the number line as well. Here, what about -5 and -7? How do these numbers compare? Which number is the larger number? And so this again might feel a little confusing because you see 7 and we're used to thinking 7 is bigger than 5, but here with these negative signs in front, actually -5 is greater than -7. -5 is a larger value than -7, and we can see this on the number line as, I guess I didn't draw it big enough, but if I extend this a little bit further left, -6 would be located here on the number line, here's -7. And so here, if I identify -7 and -5 on this number line, well, -7 lies further to the left on this number line than -5. And so -7 is a smaller number, represents less of a value than -5. -5 is greater than -7, and so that's how we can write that symbolically here. -5 is greater than -7. And negative signs and negative numbers are a great way. They really correspond to debt. Debt is a great way to think about negative numbers. And so, if you think about a credit card balance, for example, which balance has more money or, is better off? Is a credit card balance of -5 or is a credit card balance of -$7 better off? Well, a credit card balance of -5 is less in debt than a credit card balance of -7. Okay, so here we can use that to kind of think of why -5 is larger than -7, is greater than -7. It's less in debt. So you already know how to put two numbers together when they're both positive numbers, right? You know how to add, subtract, multiply, and divide positive numbers. But how do we put numbers together when there's a negative number involved? So here let's start with addition, and maybe let's just start with an example we know how to do where both of the numbers are positive, and then use this to kind of make sense of what it looks like when both numbers are negative. So here, if we have, let's say, 2 plus 4, well, you know that this comes out to 6. And we can see this on a number line. Here's the number 0. Here I'm going to start at the number 2. I'm going to go 2 units to the right on this number line. And then here adding 4 I can think of as going 4 units further to the right on this number line. So here's 3, 4, 5, 6. So here this is what it looks like to add 4 onto 2. Let's just go further right on this number line. Adding a positive number is going to move me further right on the number line. Now what does it look like if we have something like, let's say, -3 plus -5? What is this equal to? Well, here if we use our number line, maybe I'll write 0 here, here's -1, -2, -3. -3 is going to start out 3 units to the left of this number line. And adding on -5 is going to shift me 5 units to the left, right? Adding on 5 shifts me 5 units to the right. Adding on -5 ought to shift me 5 units to the left. So here I'm going to write down 5 units further left. Here's -4, -5, -6, -7, -8, right? 5 units further to the left lands me at the number -8 on this number line. Okay, so this is plus -5. And hopefully this makes sense. If you think about negative numbers as representing debt, then 2 plus 4, that's like saying I have $2 plus $4 coming together to be $6. If negative numbers represent debt, then I can think of this as saying I have $3 in debt. I also have $5 of debt, and together this makes a total of $8 in debt. Right? Negative numbers I can think of as representing debt, and when I add them together, well, I'm just more in debt. Now, what if we add two numbers where the signs differ? Let's say I add a positive number, positive 2, and I add that with -5. Well, here, we've really got all the ideas to compute this. So here, if I imagine, here's 0, 1, and 2. Here's -1, -2, -3, positive 3. Well, here, having 2 and then adding on -5, well, 2 is going to start me off 2 units to the right. And then adding on -5, we said adding on a negative number is going to shift us that many units to the left, right? So 5 units to the left, I'm going to go, 2 units to the left and then 3 units to the left some more. And so this is going to end up with us at the value -3. And so here, this is what it looks like to add on -5, is to shift 5 units to the left. And 5 units to the left of 2 is going to be the value -3. And this again makes sense with the debt analogy, is that if I have $2 and I owe 5, well, I can pay some of that off, but I can't pay all of it off. I still owe $3. And that's what it means to have the value -3 as a result. I owe $3. So here next, let's look at this reverse. Let's say we start with a negative number and we add on a positive number. So -7 plus 8. What is this equal to? I definitely encourage you to guess before we reason through this with a picture. So here's 0. Here's -1, -2, -3, -4, -5, -6, -7. Okay, so here, -7, that's going to start me off 7 units to the left of this number line. And then adding on 8, well, that's going to shift me right 8 units on this number line, right? We said adding a positive number moves us right, adding a negative number moves us left. Well, adding 8 units, I'm going to add the 7 units and then 1 more. And I'm going to end up at +1. And if I have $7 of debt, I have $8, well, I could pay it all off and I'd still be $1, I still have $1 left over. And then one last example. Let's say I have -7 plus 5. So what is this equal to? So I definitely encourage you to pause and think about this, see if you can do it yourself for a moment. So it's not going to be 12 or -12. I'm not adding 7 and 5 together. right? Negative 7 added with 5, I can think of as having $7 in debt. I have $5, well that means I can pay off some of that debt. Not all of it, I would still be left with $2 in debt. The result is negative 2. And we can kind of see that here. If I imagine instead of, I started at negative 7, but instead of adding 8, I add on 5. Well, I'm only going 5 units now to the right. And that ends me at negative 2. That brings me to negative 2. And so we can see in these 3 different examples, we added a positive number and a negative number together, and we got different values out, right? We got a negative 3, we got a positive 1, and we got negative 2. So adding numbers with different signs, it's not always going to give you a positive number. It's not always going to give you a negative number. Really, it depends on which number is kind of bigger, right? They kind of work against each other, adding a positive number and a negative number together, and whichever one's more, that's gonna tell us the resulting sign of our answer. Right? If I have more debt than I have money, well then I'm gonna still be left over with some debt when I try and pay off some of it. And so that's gonna tell me that I have more of a negative number in my final result if I add on a small positive number with a large negative number. So here, maybe we can write these ideas down. So, the first things we notice were that if we add 2 numbers, with the same sign, so what I mean by sign here is whether it's positive or negative, this produces, actually I don't think I need a comma there, so adding 2 numbers with the same sign produces a bigger number with the same sign. Right, if I have 2 positive numbers added together, well, it's going to be more of a positive number. It's going to go further right on this number line. If I have, some money, I add on more money, I'm going to have even more money. If I, add on 2 numbers with the same sign, but they're negative, well, this is going to produce a bigger number with the same sign in the sense that it's going to be more negative, right? If I have some debt, I add on more debt, I'm going to have even more debt. I'm going to have more of a negative number. And so here, when I say bigger in this example, I don't mean bigger as in a larger number left, right on the number line. I mean more of a negative number. Okay, so what about when we add 2 numbers with different signs? So here, adding 2 numbers with different signs. Maybe I'll write it this way. They kind of undo each other, right? We saw that they sort of work against each other. If I have money and I have debt, they kind of cancel each other out, and the larger one takes over. Right, so here, adding 2 numbers with different signs undo one another. And the result keeps the sign of the bigger number. And so again, I have bigger in quotes here because, earlier we said that bigger numbers are on the right, smaller numbers are on the left when we look at a number line. Here, when I say bigger, I mean in the way that we might be used to, that like 7 is bigger than 5 or 8 is bigger than 3. And so here, if we add 2 numbers with different signs, they kind of undo one another, and the result keeps the sign of the bigger number. Right? We saw here that we added 7 and 8, negative 7 and positive 8, and they worked against each other, and we had one positive number left over. Right? If I have money and debt, they cancel each other out. There's $1 left over, and that fact that 1 is positive there is because positive 8 was the bigger number here. Or if I have 2 added on with negative 5, Well, the result is -3 because there's more debt there. There's more of a negative quantity in that sum. And so here, these aren't rules that I really expect you to memorize. I just hope they kind of feel natural to you, or you sort of understand them in terms of money and debt. I think that's probably the simplest way to think of how we can add two positive and negative numbers together. So here, maybe let's do two more examples in the same spirit. Let's compute -9 plus 6, and let's evaluate -8 plus -3. And this is where I definitely encourage you to pause the video and try these examples out yourself now that we've really worked through a handful. So -9 plus 6, so what does this come out to be? So this comes out to be -3, right? If I have $9 of debt, I have $6, I could pay off some of that, but I'd still be $3 left over in debt. And we can also visualize this with the number line. Maybe I'll just draw a rough sketch. So here's 0, here's -9. If I add on 6 to -9, well, I'm not going to go all the way past 0. I'm only going to go some of the way. 6 units to the right of -9, well, this is going to land me at -3. And so that's the result here. What about -8 plus -3? Well, this comes out to be, we're adding two numbers with negative signs. It's going to make it more negative. This comes out to be -11. I have $8 in debt, $3 more in debt. I'm going to be I'm going to have $11 in debt. And so here's 0. I go down to -8. And then I go $3 further. Adding a negative number is going to move me further left on this number line. I'm going to be at -11. So let's talk about subtraction now. So subtraction can get a little tricky or confusing when we start dealing with negative numbers. So maybe let's start with an example we're very familiar with. Here, if we take 9 and we subtract away 5, what do we get? Well, we end up with the value 4. And if we look at this on a number line, right, here's 0, here's 9. And then if I subtract away 5 and I end up at 4, right, we can see that as going, left 5 units on this number line. And what did we say earlier amounted to moving left on this number line? Well, moving left on this number line was like adding a negative number. Right, adding a positive number moved us right, adding a negative number moved us left. So we can really see this 9 minus 5, this is the same as 9 plus -5. Right, 9 plus -5 is equal to 4. If I have $9, I have $5 in debt, I can pay some of it off, and I would still have $4 left over. And this might feel like a little bit of a confusing thing to do. Why would we do this if we know how to evaluate 9 minus 5? Well, actually, this translation works pretty well when we want to start subtracting negative numbers together. And so here, maybe I'll just say how this works. Is that if we want to subtract, of course, if you know how to evaluate this without any worry, go for it. But when we start dealing with more confusing examples, what we want to do when we're dealing with subtraction is we want to interpret this subtraction as adding the opposite of the second number. Right? So here, subtracting away 5 is the same as adding the opposite of 5, which is -5. Right? So here, in order to perform this subtraction, we can change the subtraction to addition, change the sign of the second number, and then we can add the two quantities together. And this might feel a little bit confusing, but we just went through a bunch of different examples of how to add two quantities together, And so we know how to add. We really do, even when numbers are positive and negative. And one common technique in mathematics is to take a problem you don't know how to do and convert it into one you do know how to do. And so this process here is just making us convert this problem into one we know how to do, an addition problem. And so here, let's take a look at a few examples. So here, let's imagine subtracting 2 and 3, so 2 minus 3. Well, here, if we kind of go through these steps, this is the same as taking 2 and adding the opposite of 3. So here I'm going to add, instead of subtract, I'm going to add the opposite of this second number. So adding the opposite, I'm going to write adding negative 3. Well, 2 added on with negative 3, this is going to be negative 1. If I have $2, I have $3 in debt, I can pay off some of the debt, but I still owe $1. And that's really the value of this subtraction here. 2 minus 3 is negative 1. What about negative 3 minus 3? So what is this equal to? And this is where things get really confusing, is because you might look at this 3 and this 3 and say, well, if I subtract them, I should get 0. But actually, really, this is the same as negative 3. And then minus 3 is the same as adding on negative 3, right? Minus 3 is the same as adding on the opposite of this second number. Well, the opposite of that 3 is negative 3. And then we know how to add on negative 3 and negative 3. That's $3 in debt. 3 more dollars in debt. That's $6 in debt. And so it's not 0, it's actually negative 6. It's more negative. Okay, what about examples where the second number is negative? What if I have 4 minus negative 1? So here, 4 minus negative 1, if we kind of go through the same steps again, we're going to, instead of subtraction, we're going to write this as addition of the opposite second number. So adding on the opposite of negative 1. Well, the opposite of negative 1 is positive 1. And so here I just wrote the second plus sign here. It's not meant to be an operation. It's meant to tell us the sign of this number. It's a positive 1, not a negative 1. 4 plus 1, that's equal to 5. And so we added on the opposite of the second number. And the opposite of negative 1 is positive 1. And so 4 plus 1, it's equal to 5. And then the last example I'd like to go over like this is negative 1 minus negative 5. I definitely encourage you to take a moment, think about what you would do to evaluate this question. Well, we would take negative 1, and instead of writing this as a subtraction problem, we can write it as addition by adding on the opposite of that second number, negative 5. Well, the opposite of negative 5 is positive 5. And so negative 1 plus 5, if I owe $1, I have 5. I can pay some of that off, and I still have $4 left over. And so here, we look at this kind of question, and it might look very confusing, but when we convert it into an addition problem, it's actually not so bad. So this is a nice approach to keep in mind. Another thing I want to mention that I think confuses some students is that there's this, maybe I'll look at this third example we have. So there's this kind of negative sign and there's this negative sign. And I want to emphasize what they mean and what their differences are. So here, this sign, this is an operation. This is a subtraction sign. This is telling us to subtract two numbers. This is a very different meaning. It's not telling us to subtract anything. It's telling us what kind of number this is. So this is telling us this is a negative sign. This is a negative number, negative 1. And these have two different meanings. The negative sign is telling us, it's describing the kind of number we're dealing with. The subtraction sign is saying, how can we put these two numbers together? And so just know that this isn't saying minus 1. It's saying subtract away negative 1. So this is a subtle difference, but I think knowing this difference can save some confusion down the road. So here, let's go through two more examples just to really solidify our understanding of subtraction with the negative numbers. Let's determine negative 8 minus 5, and let's determine negative 12 minus negative 25. So I encourage you to pause, try these examples out, and when you're ready, resume the video. So negative 8 minus 5, this is not negative 3. So here, this is the same as negative 8 plus negative 5. And if I think of my debt analogy, if I owe $8, I owe 5 more. I really owe 13. This is negative 13. What about this next example? If I have negative 12 and I subtract away negative 25, well, actually subtracting that negative really is the same as like adding the positive, right? So here, if we convert this to an addition problem, I'm going to add the opposite of the second number. Well, the opposite of negative 25, that's positive 25. And then adding negative 12 and 25 together, they're going to kind of undo each other. And I'm going to have $13 left over if I'm thinking of this in terms of debt, right? If I owe 12 and I have $25, I can pay off that 12, but I still have $13 left over. That's my own. So now let's talk about multiplication and division involving negative numbers. Actually, this ends up being a little bit friendlier or clearer than maybe addition or subtraction. And so maybe I'll just outright say what we do when we multiply or divide negative numbers and positive numbers together. So here, if the signs match, in other words, we're multiplying a positive number together and a positive number, or a negative and a negative number together, and we're not mixing their signs, then the result is going to be positive. And if the signs don't match, then here the result is going to be negative. If we have a positive and a negative number multiplied together, or a negative and a positive, the result is going to be negative. And so here let's take a moment to understand this first, because I think this is the easiest to explain. So if we continue with this money analogy. Right, so here, if I give you, let's say I give you 3 $20 bills. Right, this is the same as you getting this $60, which I can see this as 3 times 20. Right, 3 times 20 is 60. This is like saying I'm giving you 3 sets of $20. And so here you gain 60. So that's one way to visualize this multiplication. 3 times 20 is 60, is I'm giving you 3 sets of $20 bills. What if I give you 3 $20 debts? Well, I can view this as 3 times negative 20. I'm sort of giving you 3 sets of $20 debts. You're going to get negative $60 essentially. You're losing money here. If you're gaining more debt, you're losing money. Another way I can imagine making you lose money, it's a very mean thing to say, but so just for the sake of example, so let's say I take 3 $20 bills from you. Right, so here I can view this as negative 3 times 20. Right, so here instead of giving you 3 sets, I'm sort of taking away 3 sets of $20, and here again you're losing $60. And so here this is really just to illustrate that when we multiply two numbers where one sign differs from the other, 3 times negative 20 or negative 3 times positive 20, either way you're losing those $60. The result is this negative quantity. Right, so if the signs don't match when we multiply two numbers together, the result is going to be negative. And then this last example is probably the least clear, but maybe I'll just write it down for the sake of completeness. If I take 3 $20 debts from you, and I can kind of view this as negative 3 times negative 20. Well, if you're losing debt, in some sense you're kind of gaining money. You're kind of gaining $60. You're losing $60 of debt. That's losing money that you owe. In some sense you're gaining money, but it's harder to really understand that. It's less clear. So if this last example doesn't make perfect sense to you, that's okay. But here this is really just to illustrate that if we multiply two numbers with the same sign, 3 times positive 20, negative 3 times negative 20, the result's positive in either case. And so here, when the signs match and we multiply or divide, actually, division actually follows the same rules, we get a positive result. And so here, let's work through a handful of different examples just to really get used to this idea. Right, if I take 3 times 15, now this is the one we're probably most familiar with, 3 times 15. This is going to give us 45, the result positive. If I take negative 4 times 5, well, here the signs differ between these two numbers. We multiply just like we normally would, 4 and 5, but we just know that the fact that the signs are different makes the result negative. So this is negative 20, negative 4 times 5. Now what if I do something like negative 2, and then I write in parentheses negative 6? So here, this might be a little bit confusing to look at. Here, this is where that idea of this being a negative sign and not subtraction is actually kind of important. And so I know there's parentheses there, and sometimes we view parentheses, you might naturally want to view parentheses as multiplication, but here actually this is multiplication again because there's no operation between these two quantities. And again, so this is not a subtraction. This is not telling me to take negative 2 and subtract away negative 6. This is telling me we're looking at the number negative 6, right? We're taking negative 2, and there's no operation between these two numbers, so we multiply them. And so we're multiplying negative 2 and negative 6. There's no subtraction here. And so how do I multiply these two numbers? Well, the two signs are the same. It's a negative and a negative. And so this is going to give us a positive result. Positive 2 times 6, that's positive 12. Now what about 2 and then in parentheses negative 1? Again, this is multiplication because there's no operation between these two quantities. This symbol here is just there to tell us that we're dealing with the negative 1 quantity. That's the second number. And so we're multiplying these two numbers together, and this gives us, this gives us a negative result, negative 2. It's going to be negative 2 times 1, so negative 2. And so here, maybe just to be clear, we have these parentheses here just so that we don't have two operations listed right next to each other, right? If I have something like 2 minus, maybe I'll write this in a different color. If I have something like 2 minus negative 3, this is kind of confusing to look at. And so we really wrap parentheses around this second negative symbol here, just to really emphasize that this is a number and this is an operation. So we might see that also with multiplication if we have 2 times negative 3. This kind of seems confusing to have the two, they could be confused as operation symbols here. So we wrap this second quantity in parentheses to make sure that it's clear that this symbol here is there to tell us that this is a negative number, not subtraction. And so I said that these properties of multiplying two numbers together and then their signs also is valid for division, right? So if I have something like 15 divided by 3, well, these two numbers are positive, so this comes out to the positive number 5. If I have 16 divided by negative 8, well, what is this going to be equal to? Well, I perform the division, 16 and 8, that's 2. And then it's going to be negative because the signs differ. If I take negative 28 and I divide this by 4, this is again going to be negative because the signs differ, and this is negative 7. And then lastly, this is, if I take negative 36 and I divide by 9, well, here we get negative 4. 9 goes into 36 4 times. The signs differ, this is negative. And so let's take a look at two more examples here. So let's determine negative 9 times 7 and negative 2 times negative 2. So pause the video, try these out yourself, and then we can go over them in just a moment. So this first example, well, 9 times 7 is 63. And here the fact that the signs differ gives us the result negative 63. So here, the next example, we have negative 2 times negative 2, right? This is multiplication. So the signs are the same, our result is positive, and then 2 times 2 gives us 4. And so the idea I'd like to end on is, we just described how dividing negative numbers works, what the result will be based on the signs involved. And then these ideas are valid for fractions as well. So, right, fraction bars are used to describe division. And so when we're dealing with fractions and there's some signs involved, we can use these rules about dividing signed numbers to determine the result of the fraction too. Right, so here if I have 48 and I divide this by the number negative 12, well, here I'm taking a positive number, dividing it by a negative number. My result should be negative. And 12 goes into 48 4 times. This is negative 4. What if I take negative 48 and I divide it by 12? Well, this is going to give us the same result actually, right? This is going to give us, this is a negative number divided by a positive number. The signs differ, so it's going to be negative, and 12 goes into 48 4 times. What if I take negative 48 over negative 12? Well, the signs are the same, so the result is going to be positive 4. And here, this is a little bit different, but maybe I'll write this out. Actually, I'll write it out without parentheses. If I have negative 48 over 12, well, this is like saying I have a negative number, negative whatever this number is. And so this is the same as negative 48 over 12 is 4, right? So this is negative 4. So if I have that negative sign outside of my fraction, not in the numerator or in the denominator, it's just saying the negative of whatever this number is. And in this case, 48 over 12 is the number 4. So as a whole, this is the number negative 4. So sometimes people read this and their first guess, their incorrect guess, is that this is the same as, well, we would just distribute that negative sign to the top and the bottom, negative 48 over negative 12. But we saw that, that's incorrect because that ends up with this positive number where we know that this is really negative. So here, don't make that mistake. This is one of those things that I just really like to point out and make clear. And so another thing that I like to make clear here is that these 3 examples were the same. Right, these 3 different fractions, where the negative sign was positioned, resulted in the same answer at the end of the day. We ended up with a negative 4. And so actually, you can go back and forth between any of these 3 different fractions. Let's say you have this fraction here. Well, this is the same as this fraction. So if you wanted to rewrite it that way with the negative sign in the numerator instead of the denominator, that's also valid. And you could also rewrite it with the negative sign outside of the fraction as a whole, if that made your problem, dealing with your problem, easier or clearer. So here we can switch between all these 3 different examples because they all represent the same number. And so usually if we have a choice, we'll actually represent the fraction this way. This might be called, your book calls it the standard form of this kind of fraction. So here, when we have a negative sign involved in a fraction, we'll usually have that negative sign in the numerator.